Assalamu alaikum wa rahmatullahi wa barakatuh. Inshallah, we're going to start with chapter 11, trigonometry, and this chapter is just about the basics for the trigonometry and most of the rules that you might have in the SAT questions. So let's start with the basic trigonometric formula here. I'm dealing here with a right angle triangle. And you know that inside the right angle triangle, the side would be the hypotenuse because it's opposite to the right angle. And here I'm considering angle A. I'm trying to take the sine and cosine and tan for angle A. So here, this would be the opposite side, and this would be the adjacent side. So if I need the sine, would be opposite over the hypotenuse, which means A over C. If I need the cosine, it would be the adjacent over the hypotenuse. So it would be B over C. If I need the tan is the opposite over the is adjacent. It would be A over B. Also, we have here the reciprocal for the sine and cosine and tan. If I'm asking you about the reciprocal, this means this is cosecant A. Now, cosecant means it's the reciprocal of sine A. It's 1 over sine A. So this means I'm just flipping the fractions. It would be C over A, which means that I'm taking the hypotenuse over the opposite. And for the reciprocal for cosine A, it would be secant A, 1 over cosine A. So I'm just flipping it. So this means I'm taking the hypotenuse over the adjacent. And if I'm taking cotan A, cotan means the reciprocal for tan. So it would be 1 over tan. So it would be the adjacent over the opposite. Here is the unit circle. Unit circle means that you have a circle centered at the origin, 0 and 0, and its radius is 1 unit. So this point would be 1 and 0. Each point on the circle represents x and y, right? And the x here equal to the cosine of theta and the y here equal to the sine of theta. So at this point, this is a 0. I'm starting from here. The cosine of 0 would be 1 and the sine of 0 would be 0. Okay, so I'm starting from the positive x-axis and I'm going a full round till the 360. 360 again is a complete turn and it's equal also to 0. So 1 and 0. So the cosine here of 360 would be 1 and the sine for the 360 would be 0. Now, if I'm doing here a right angle or I make 90-degree, so I'm reaching here to this point, which is 0 and 1. So the 0 here would be the cosine of 90, and the 1 here is the sine of 90. Going here to make a half circle, which means I'm reaching 180-degree. And as you see here, 180 degrees, this means that you go for the negative direction of x. So I'm just changing the sign of the x coordinate. It was here 1, so I will make it -1. So the -1 here would be the cosine of 180, and the 0 here would be the sine of 180. Now, completing my turn, I reach it to 270-degree. And as you notice here, I'm going for the negative direction of the y-axis. So this means I'm going to change the sign of the y-axis. This was 0 and 1. Here it would be 0 and -1. So the 0 here is the cosine of 270. And the -1 here is the sine of 270. As you see here, is the unit circle is very symmetrical. And knowing these facts, you're gonna know how to get the sine and cosine and tan for most of the angles, if you understand this. Now going for the basic angles and the trigonometric formula for them. I need you to understand or memorize from 0 to 90. I'm going to give you a trick to deal with it. Start. From sine, you start from 0 to 1. For cosine, you start from 1 to 0. And here, this value all the time would be fraction with denominator 2. Put it in order. 1, root 2, root 3. 1, root 2, root 3. Flip the order in the cosine. Root 3, root 2, and 1. What about the tan? You just divide the sine and cosine. Here it would be 0, 1 over root 3, root 2 over root 2 give you 1, and root 3 over 1 give you root 3, and 1 over 0 is undefined. Knowing these angles, we call it reference angles. Knowing these, you're gonna deal with the other angles in the unit circle. Let me explain with you the unit circle now. We already know about the reference angle here in the first quadrant, right? Now we're gonna use these to know the rest of them. As you see here, this is the second, this is the third, and this is the fourth. In the second quadrant, to get the reference angle, you're gonna say it's 180 minus theta, and you have to change the cosine. Sine. Change the cosine because you are in the negative direction of the x-axis. You have to be negative, okay? Okay, now for the third, now you are in the negative direction and the negative direction of x and y, right? Good. So I have to change both the sine and cosine. But how to get the reference angle? I'm gonna say theta minus 180. And I have to change the x and y, which means I have to change the cosine and sine to be negative. In the fourth quadrant, how to get the reference angle? I'm gonna say it's 360 minus theta, and I have only to change the y direction because now I'm in negative direction of the y, but still in the positive direction of x. So I have to change sign. Good. Now, let me give you an example to understand what I'm talking here. I'm giving you theta equal to 120. And I'm asking you, I need the sine and cosine and tan for it. So these are not, this is not a reference angle for me, right? So I have to get it first. It's in the first or second or third or fourth quadrant. It's a second. So this means I'm gonna use the rule 180 minus theta. So the reference angle here is 180 minus theta. So 180 minus 120 give me 60. So the same value for sine and cosine, but I have to change what? I have to change the cosine because I'm the negative direction of x. So the sine of 120 is the same as sine of 60, which is root 3 over 2. And the cosine of 120 is the negative of the cosine of 60. So it would be negative 1 over 2. And what about the tan? We agreed. We divide those. So root 3 over negative 1 give me negative root 3. Let me give you another example. Theta equal 210. This is not a reference angle, so I need to get it. This is in the third quadrant, so I'm going to use theta minus 180. So theta equal 210 minus 180. So the reference angle here would be 30. Good. So this means the same values, but I have to change what? I have to change both the sine and cosine. Sine. So let me see. So the sine of 210 is 1 over 2, but I have to change the sign of it. And the cosine of 210 is negative root 3 over 2. What about the tan? We just dividing. So negative 1 over negative root 3 give me 1 over root 3. Okay, here another example. Theta equals 315. Now this one is the fourth quadrant. So I'm going to say 360 minus 315. So the reference angle here is 45. So the same sine and cosine, but I have to change what? I have to change the sign of the sine trigonometric function. So here, the cosine of 45, it gives me root 2 over 2. But I have to change the sign. Here, it will be negative root 2 over 2. What about the tan? I'm just dividing root 2 over negative root 2, so it would be negative 1. Now, this proof whatever we explained before. This is talking about the trigonometric function sign in each quadrant. Here, all of them are positive, the sine and cosine and tan. In the second quadrant, you have just only the sine is positive, and in the third quadrant, just the tan, and the fourth quadrant, just the cosine. So you could make it easy for yourself. All students take calculus or ASTC. A all is for sine, and T for tan, and C for cosine. So your A, S, T, C. All of them in the first quadrant positive. Only sine in the second quadrant is positive. In the third quadrant, only T. And in the fourth quadrant, only the cosine. Now, how to convert from radian degree and degree to radian. For example, I have here 60 degree and I want to convert it to radian. So I'm going to say 60 times pi over 180. So here, 60 for 7 pi, so it would be 3. So pi over 3. Now I have pi over 6 in radian and I want to convert it to degree. So I'm going to say pi over 6 times 180 over pi. Pi goes by, so 180 over 6 give you 30 degree. Now, how do you know the arc length? What is the meaning of arc length? As you see here, is the theta here represent a central angle. And if you want the length of this arc, I'm making here, so it would be r times theta, and the theta here should be with radian. So for example, if I'm saying I need the arc length for theta pi over 3, and the radius is 6. The radius is 6, and the theta is pi over 3. So it would be S equal the radius 6 times pi over 3. So here it would be 2 pi. Okay, here, this is another trick for you if you cannot handle the unit circle and how we get the trigonometric rules from it. You could use the triangle. We have the 30, 60, 90 triangle and the 45, 90 triangle. For the 30, 60, 90 triangle, all the time the hypotenuse would be 2, and here root 3, and here is 1. So 1, root 3, and 2. Okay, now for the 45, it would be 1 and 1 because it's isosceles triangle, and the hypotenuse would be root 2. So let's see how we get it now. If I need the sine of 30, where is 30? Here is 30. Where is the opposite side? It's 1. And where is the hypotenuse? It's 2. So 1 over 2. If I need the sine of 45, where is the opposite side for 45? It's 1. And where is the hypotenuse? It's 2. So 1 over root 2. Sine 60, where is the opposite side for 60? It's root 3. And the hypotenuse is 2. Root 3 over 2. And so on. Another information I need you to know. this is the theta, and this is the adjacent side, and this is the opposite side. If you need to get the opposite or the adjacent side, we could apply this. The x is r cosine theta, and the y equal to r sine theta. And you remember that the r, just like Pythagoras theorem, I need the hypotenuse. This is the hypotenuse, right? This is a right angle triangle. So if I need to get the r, I'm going to take the square root of x power 2 plus y power 2. And for theta, if you need to get the theta, you could get the inverse of the tan. What is the meaning of the inverse of the tan? Which angle you have, which angle has this tan after you get it? Of course, because we know يعني the basic and the reference angles, we're not gonna use calculators, so we need to memorize this. Cosine t, if cosine t equal 4 over 5 and t in the first quadrant, then the cosecant c equal. Now, the cosecant mean 1 over sine, which mean it's a hypotenuse over the opposite. So, I don't have the sine, but I know the cosine. This is t, right? And the cosine is the adjacent over the hypotenuse. This is 4 and this is 5. So, by Pythagoras, this would be 3. So, 1 over sine, the sine would be 3 over 5, and the cosecant would be 5 over 3. Now, if secant theta equals 17 over 8, secants mean 1 over cosine. And this means that the cosine would be 8 over 17. Good. So here, this is theta, and this would be 8, and this would be 17. Now I need this one. By Pythagoras, this would be 15. And actually, if you cannot do it with Pythagoras, just look at the choices. So here, this means that the tan would be 15 over 17. Find the value of y in the triangle where the hypotenuse is 10 and the angle is 30. So here's the triangle. This is 10, and this is the angle theta 30. This is the y, and this is the x. So here, I need the y. The y equal r sine theta. So the r here is the hypotenuse. R equal to the hypotenuse, which is 10. And we know the formula of the circle, y equal r sine theta. So 10 sine 30. Now, sine 30 equal what? Sine 30 equal half. So 10 times half give me 5. If sine theta equal half, then theta. So yes, sine 30 equal to half. So here's it. A lighthouse is 80 meters tall and a ship is seen from the top at a depression, angle 45. What is the horizontal distance? Okay, here's the lighthouse. And here's the ship. You're looking at it with an angle of depression. This is the angle of depression, 45. And it's 80 meters tall. So here, this is 80 meters tall. And this is the horizontal distance. Now, of course, this is 90, and he's asking you about the horizontal distance. Since it's 45, this means this is an isosceles triangle, right? So it would be also, this is 45. So this would be equal to 80. This side would be equal to 80. The value of x that satisfies the equation cosine 60 equal x over 4. Now, cosine 60, it's 1 over 2. So 1 over 2 equal x over 4. So x equal cross multiplication. So 4 over 2. Give me 2. Which two angles make cosine theta equal 0 and tan theta is undefined? Tan theta is undefined when angle is 90, right? Do you remember the unit circle? This was 0 and 1, and this one was 0 and the -1. Here, 1 and 0, and here's -1 and 0. So it's undefined here, the tan of theta, because you divide 1 over 0. And also it's undefined here because you're going to divide -1 and 0. And the cosine here is 0, and the cosine here is 0. This is 90, and this is 270. Which angle is a counterexample to the identity sine theta plus cosine theta equal 1? Okay, let me remind you the unit circle. This is 1 and 0, 0 and 1, -1 and 0, and here 0 and -1. Counterexample mean a wrong answer. So this means I'm searching for something that doesn't give me 1. So if I add them here, it gives me 1. If I add them here, it gives me 1. If I add them here, it gives me -1. And if I add him, it also gives me -1. So the counterexample for it would be 180 or 270 because it gives me -1. So here's the answer. Which of the following angle has both sine and tangent negative? Okay, let me remind you. ASTC. Cos is positive here, sine is positive here, and tan is positive here. Cosine is positive here. So I'm searching for something both sine and tangent are negative. So it would be only in the fourth quadrant. So this means it's greater than 270. So I'm searching for angle here greater than 270. So it's 310. If sine theta equal 4 over 5 and theta from 90, 90 smaller than theta, smaller than 180. So it's between 90 and 180 in the second quadrant. Then cosine theta equals, okay, do you remember all sine, tan, cosine? We are in the second quadrant. So the sine is the only trigonometric function which is positive, right? Good. So this means that the cosine and the tan would be negative. And I'm asking about the cosine. So I'm searching for a negative value, right? So maybe it's -5 over 3 or -3 over 5. But of course, this is the hypotenuse, right? 5. So this is my answer. For question 12, if cosine theta equal -5 over 13 and theta between 180 and 270, this is the third quadrant. So this means this is the tan only, which is positive. The sine and the cosine should be negative. So I'm searching for something which is negative. So maybe it's -12 over 13 or -5 over 13. Of course, by Pythagoras, it would be 5, 12, 13. So my answer is -12 over 13. What is the value of sine 420? 420, this is greater than a complete circle, which is 360. So I have to subtract. So 420 minus 360 give me 60. So this means this would be the same as 420. So what is the sine of 60? Sine of 60 is √3 over 2. Question 14, the angle 5 pi over 3 in degrees equal. So he wants me to convert from radian to degree. So here, I'm going to multiply 5 pi over 3 times 180 over pi. Cancelled here. 3 here would be 60. So 5 times 60 give me 300. The arc length of a quarter circle with radius 8. Arc length, let me remind you the rule, S equal R theta, and theta should be with radian. And he say quarter circle, so this is 90. So 90 in radian would be pi over 2. So 8 times pi over 2, so it will be 4 pi. The area of triangle with two sides 10, 13, and the angle between them is 90. So here, the area equal half AB sine theta. So it would be half times 10 times 13 sine 90 Sine 90 equal 1. So here, I will just remove this and multiply by 1. So equal to 5 times 13 give me, I think it's T5.